Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 4 Vectors and 3-dimensional Geometry. Topic 3-dimensional Geometry. Subtopic Coplanar lines, angle between two planes, distance of a point from a plane, angle between a line and a plane, conditions for perpendicularity and parallelism. Exercise 11.3. 1. Find the equation of a plane in Norman form. Let ON be the Norman from the origin to the plane, and n cap be the unit vector along ON. ON haibasi origindagi plane aduda singakpa Normani. N cap haibasina ON gi paringda satpa unit vector ni. Then ON vector equal to d times of n cap. Let P be any point on the plane. Then NP vector is perpendicular to ON vector. So NP vector dot ON vector equal to 0. Equation 1. Let R vector be the position vector of the point P. Then NP. NP is R vector minus the N cap. Therefore, equation 1 becomes R vector minus the N cap dot the N cap equal to 0. D na divide tokhrabadi we get this. Amuksu N scalar pangthobadi R vector dot N cap equal to N dot N d 1. That becomes D. R vector dot N cap equal to D. This is the equation of the plane in vector form, where n cap is a unit vector perpendicular to the Norman drawn from the origin to the plane. D is the distance of the plane from the origin, and R is the position vector of any point on the plane. Let P, whose coordinates are x, y, z, be any point on the plane, and L, M, N be the distances of the Norman. Then OP vector equal to x times of I cap plus y times of j cap plus z times of k cap, and N vector equal to L I cap plus M j cap plus N k cap. Using R vector dot N cap equal to D, we get R vector की equivalent value पिछन क्रसी we get this, and the N cap की value in terms of components ta sinjalasi. Vector anisi की dot T L times of x plus M times of y plus N times of z equal to D. This is the equation of the plane in Cartesian form. In this equation, L, M, N are the direction cosines of the Norman to the plane. D is the distance of the plane from the origin. X, Y, Z represents the coordinates of any point on the plane. Number 2. Find the equation of a plane perpendicular to a given vector and passing through a given point. Apiba vector amada perpendicular oiba apiba point ama phawba plane gi equation putu. Let A be the given point whose position vector be a vector, and P be a point on the required plane whose position vector be R vector. Let N vector be the given vector perpendicular to the plane. As in this picture, A represents the given point whose position vector be a vector, and P be a point on the required plane whose position vector is also taken as R vector. N vector is the given vector perpendicular to the required plane. Then AP vector is equal to position vector of P, that is R, minus position vector of A, that is A. Also, AP vector is perpendicular to N vector. Therefore, their dot must be 0. That gives R vector minus A vector dot N vector equal to 0. This is the equation of the plane in vector form. In this equation, R represents the position vector of any point on the plane. A is the position vector of a given point on the plane. And N vector is a vector which is perpendicular to the required plane. Let A equal to x1, y1, z1. Let the coordinates of A be taken as x1, y1, z1 and that of B be taken as x, y, z. Direction ratios of the Norman be taken as ABC. Then A becomes x1 times of ik plus y1 times of jk plus z1 times of kk. And position vector are equal to x times of ik plus y times of jk plus z times of kk. And the Norman vector is equal to aik plus bjk plus ckk. Using r vector minus a vector dot n vector equal to 0, we get, putting the value of r here and that of a in this here, and n is replaced by its equivalent value. Actual scalar product, the scalar product of these two vectors gives a times of x minus x1 plus b times of y minus y1 plus c times of z minus z1 equal to 0. This is the equation of the plane in Cartesian form. Here A, B, C are the direction ratios of the Norman to the plane. x1, y1, z1 are the coordinates of the given point. x, y, z represents the coordinates of any point on the line. Thus, we are given the direction ratios of a Norman to the plane and the coordinates of a point are given, then we can write the equation of plane using this formula. For 3, equation of a plane passing through 3 non-collinear points. Line amada leitaba point ahum phauba plane equation puthoksi. Let A vector, B vector, C and C vector be the position vectors of 3 non-collinear points A, B, C respectively. As in this picture, A की position vector दुना respective letter A vector ना खांगना दसी, B की position vector दुना corresponding vector B vector ना खांगना दसी, C हारी बापी बा point ना C की position vector दुना C ना खांगना दसी. The vectors AP and AC are in the plane. AB have a vector, siga AC vector have a siga require plane the yawa vector singni. So AB vector cross AC vector is perpendicular to the plane containing A, B and C. AB vector cross AC vector have C, A, B, C point ahum si yauba plane to the perpendicular oigani. Let R vector be the position vector of any point P on the plane. Plane adu parallelogram asina mahut sile ayekpa diagram asida P hariba point asi plane require plane adu any point amane mahaki position vector do R vector oina lowri with O as origin. Then AP vector habesisu plane asida leiba vector oibanina mahak asisu perpendicular to AB vector cross AC vector do perpendicular orani. Perpendicular oiba ani ki dot scalar product is 0 tarane. Then respective value AP gidi R minus A sinjin khargane, AB gidi B minus A, AC gidi C minus A equal to 0. Respective value pichela sig equation si phange. This is the vector equation of plane passing 3 non-collinear points whose position vectors are A, B and C. This is the vector equation of a plane passing through the 3 non-collinear points whose position vectors are A vector, B vector, C vector, and R is the position vector of any point on this line. Let the coordinates of A be taken as x1, y1, z1, and that of B taken as x2, y2, z2, and that for C is also taken as x3, y3, z3, and P is which is also x, y, z. Then R minus A becomes this, B minus A is also in terms of ijk equal to this, C minus A is also this. Putting these values in the above equation using equation 1, the equation of the plane is Mataki equation is scalar triple product of 3 vectors ne. scalar triple product of three vectors to sizinaragadi Sigi value singsamataki equation the sinjalabadi we get this determinant equal to 0. This is what? This is the equation of a plane passing through three non-collinear points. Four. Find the equation of plane in intercept form. Intercept form of plane put to haibani. Solution. Let the equation be ax plus by plus cz plus d equal to 0. D does not equal to 0. Let the plane make intercepts small a, small b, small c on x, y, and z axes respectively. Then the plane meets x, y, and z axes at the points P whose coordinates are a0, 0, Q whose coordinates are 0, b0, and R whose coordinates are 0, 0, c respectively as in this picture. Then point P asi plane asina phaurabadi point P ki coordinate a0, 0 na plane की equation asibu chungmani haibadi x ta a pisilo, y the 0 pisilo, z the 0 pisilo plus d equal to 0. That gives a plus d equal to 0. Masidagi a की value do minus d by a phange. Asumna q phauragana c b की value pirani, r phauragana c की value do minus d by small c orani. Capital A, capital B, capital C की value सिंग असी मथक की equation असी द सिंजलबदी. Substituting these values in equation 1 above, we get minus d by a times of x plus minus d by b times of y plus minus d by c times of z plus d equal to 0. Dividing d on both sides and transfer, we get x by a plus y by b plus z by c equal to 1. This is the equation of the plane in intercept form. These small letters ABC, what stand for small letters ABC? They are length of intercepts made by the plane on the axis respectively. 5. Find the equation of the plane passing through the line of intersection of two planes. Plane ani kaknaraga phangba line adu yauba plane ki equation puthu. Let k1 and k2 be the two planes whose equations are r vector dot n1 cap equal to d1 and r vector dot n2 cap equal to d2. Ayekba picture sida machine k1 plane aduni, machine k2 plane aduni. The position vector of any point on the line of intersection must satisfy both the equations. Line ani sigi kaknafam line ani sigi kaknaba plane ani sigi kaknaraga phangba line asida leba point khudingmakna plane ki equation animak po satisfy tawgani. If t vector is the position vector of a point on the line, then r c t ne replace tawthrabadi t vector dot n1 cap equal to d1 and t vector dot n2 cap equal to d2. Thus, for all real values of lambda, we have t vector dot n1 vector plus lambda times of n2 vector cap equal to d1 plus lambda times of d2. Since t vector is arbitrary, it satisfies both for any point on the line. Hence, the equation t asi r na replace tawthrabadi r vector equal to n1 cap plus lambda times of n2 cap equal to d1 plus lambda times of d2 represents a plane k3. Blue ne ye iba k3 have a plane asi mahut silani. For Cartesian, in Cartesian system, let n1 cap equal to a1 i cap plus b1 j cap plus c1 k cap. n2 cap equal to a2 i cap plus b2 j cap plus c2 k cap. And r vector is x I cap plus y j cap plus z k cap. Then r vector dot n1 cap plus lambda times of n2 cap equal to d1 plus lambda times of d2 becomes hariba value singasi mathaki equation asida sinjalabadi we get first plane plus lambda times of second plane equal to 0. This is the Cartesian equation of the plane containing the line of intersection of two planes, where lambda is arbitrary constant. This is the equation of the plane containing the line of intersection of two planes. Number 5. Find the condition of coplanarity of two lines. Line ani plane amada laigani haibagi condition puthu. Let the given lines be r vector equal to a1 vector plus lambda times of b1 vector, and second line be r vector equal to n2 vector a2 vector plus lambda times of b2 vector. Is in this picture see the line anidu anisina mahut sile. The first line passes the point A, whose position vector is a1 vector and parallel to the vector b1 vector. The second line passes the point B, whose position vector is a2 vector and parallel to the vector b2. Thus, AB vector is position vector of B minus position vector of A, that is a2 vector minus a1 vector. The given lines are coplanar if and only if AB vector is perpendicular to B1 vector cross B2 vector. B1 amasung B1 amasung B2 gi cross toradi upward kakhaliba vector asini. Plane line anisi coplanar oiga hairabadi line animak AB1 cross B2 vector asida haibadi mahaka perpendicular mahaka su perpendicular oigadabani. Implies AB vector dot B1 cross B2 equal to 0. AB haibasidi plane asida leiba AB hariba vector asidi plane line ani siyauba plane aduda leiba point ani samjinaraga semba vector ni. Adurabadi AB vector dot B1 vector cross B2 vector is 0 oigadabani. Perpendicular oiba ani gi scalar product 0 oigadabani. AB asidi a2 vector minus a1 vector sindokro b1 cross b2 the length thamo, which is the condition for perpendicularity of two lines in vector form. For Cartesian, let us suppose A is x1 y1 z1 and B is x2 y2 z2, and let a small a1 small b1 small c1 and small a2 small b2 small c2 be the direction ratios of b1 vector and b2 vector. Then AB is equal to x2 minus x1 times of I cap plus y2 minus y1 times of j cap plus z2 minus z1 times of k cap. B1 vector is equal to a1 I cap plus b1 j cap plus c2 k cap, and b2 vector is equal to a2 I cap plus b2 j cap plus c2 k cap. Using a2 minus a1 dot b1 cross b2 equals 0 mathaki vector form asi sijinnarabadi scalar triple product tare. Aduna first row da a2 minus a1 ge ijk gi coefficient irani, second row da b1 vector gi direction ratio sing irani, third row da b2 gi ijk gi coefficient sing irani equal to 0 manarani, which is the condition of coplanarity of two given lines. 0 into denominator, that gives the numerator equal to 0. This is the condition for two planes to be perpendicular. For parallel planes, direction ratios are proportional, that is a1 by a2 equal to b1 by b2 equal to c1 by c2. There are two angles between two planes. We take acute angle unless some conditions are specified. Plane kakhatnaba plane anigi marakta angle ani laigani aikoini acute angle logani karigumba condition khara palamdrabadi. Number 8. Find the distance of a point from a plane. Karigumba point ama karigumba plane amadagi arapa putu. Let a point A with position vector a vector B at a distance d from the plane R dot n vector equal to q. A hariba point asi apiba plane asidagi d lapa mafamda lay haina lawrasi. Let the foot of the perpendicular drawn from A on the plane be B. A hariba point asidagi plane adu chingakpa perpendicular gi makhongdu capital B oina khangnarasi. Then AB hybasi equal to small d. Distance between A and B is equal to d. And we have converted it in vector. AB vector is equal to d n cap, where n cap dot n vector is the magnitude of n vector. Let B vector be the position vector of the point B with origin O as origin. Then B vector equal to OB vector is in this picture, which is sum of OA vector plus AB vector. Their respective values are A vector plus for AB vector d n cap. Since B lies on the plane D, so it must satisfy the equation. B hariba point asina plane asida leba point oirabanina B gi position vector na plane asigi equation bu satisfy togani. Haibadi R haibasi B vector na sindokrane, others are remains unchanged. Then B gi corresponding value d A vector plus d times of n cap value pisalani. Dot n pangthoklabadi A vector dot n vector plus d times of n cap dot n vector equal to q. N sidagi di n vector n cap dot n vector the magnitude of n ga mana khare. Magnitude of n the n laikre, that gives d equal to a q minus a vector dot n vector divided by magnitude of n vector. Lastly becomes this. See equation as from a vector dot n vector q mahaka interchange tore, we get this. Let this is the distance of a point from a given plane in vector form. Let A whose coordinates are be taken as x1, y1, z1 be the point and a x plus by plus c z plus d equal to 0 be the given plane. Then the distance d becomes respective A ki value pisila, n ki value pisila, plus d, q ki value pisila minus of this, we get this divided by n vector ki magnitude divide toro simplify toro kasi phangi. This is the perpendicular distance of a point whose coordinates are x1, y1, z1 from a given plane whose coordinate is whose equation is x plus by plus cz plus d. For positiveness, we have to take magnitude on the numerator. 9. Define angle between a line and a plane. Line amaga plane amaga maraki angle define to. Find angle between a line and a plane. Line amaga plane amagi maraki angle suputu o. The angle between a line and a plane is the complement of the angle between the line and the normal to the plane. Is in this picture, parallelogram asina plane ama represent orasi brown singiba asina piba line aduni. Aduga vertically singiba blue singiba asina plane adu singba normal ni. Plane amaga asang mana singiba si plane adu da laiba line amani. Asumna angle ani si amana amagi acute and complementary oiba angle sini. Line amaga plane amaga maraki angle habesidi line aduga plane aduda singba normal ga maraki angle dugi complement aduni, that is normal ga line aduga maraki angle do theta oirabadi line aduga plane aduga anigi maraki angle do 90 degree minus theta na piba value aduni. Let the line be r vector equal to a vector plus mu times of b vector and the plane be r vector dot n vector equal to d. Line adugi equation a vector from the c on a lower c, plane equation aduna vector from the c lower c. The angle theta between the line and the normal is cos theta equal to magnitude of b vector dot n vector divided by product of their magnitudes. The angle phi between the line and the plane is phi equal to 90 pi by 2 minus theta. Sine of phi is sine of 90 pi by 2 minus theta, whose value is cos theta. Cos theta is already found to be this. Substituted its corresponding value, we get this. Sine phi becomes magnitude of b vector dot n vector divided by product of their magnitudes. Exercise 11.3. Question number 1. In each of the following cases, determine the direction cosines of the normand to the plane and the distance from the origin. Makhada piriba plane singa sida singba normand gi direction ratio cosine sing putu loinana origin dagi plane adu singa parapa dusu putu. For first plane z equal to 2. ꯑꯩꯈꯣꯏꯅ ꯃꯐꯝ ꯑꯁꯤꯗ ꯈꯪꯖꯤꯟꯕ ꯌꯥꯕꯗꯤ z equal to 2 or z equal to c. Z equal to 2 is what? It represents a plane parallel to xy plane at a distance 2 units along the positive direction of x-axis. This is a plane parallel to xy plane and at a distance 2 units from it. Therefore, direction cosines of the normand to the plane are the direction cosines of z-axis, that is 0, 0, 1, and the distance of the plane from the origin is 2. For second plane, here A is direction ratios of the normand to the plane are coefficients of x, y, z respectively, that is 1, 1 respectively. If we are known the direction cosine ratios of a line, then we can find the direction cosines of the normand. For that, we have to find out square root of a square plus b square plus c square. Putting respective values, we get root over 3. Therefore, direction cosines are L, whose value is a by root over 3. That gives 1 by root 3. And for M, B by root over 3. That is 1 by root over 3. For N, C by root over 3. That is 1 by root over 3. Which are the direction cosines of the normand to the plane. Its distance from origin is modulus of 0 plus 0 plus 0 minus 1 divided by square root of 1 square plus 1 square plus 1 square. That is 1 by root over 3. It is the distance of the given plane from the origin. For C, direction cosines are L equal to a by root over a square plus b square plus c square. We get 2 by root over 14. For M equal to b by root over a square plus b square plus c square. That is 3 by root over 14. Similarly, N is minus c by root over a square plus b square plus c square. That is minus 1 by root over 14. As square root of a square plus b square plus c square is square root of 2 square plus 3 square plus 1 square. That gives square root of 14. Also, its distance from origin is, put x equal to 0, y equal to 0, z equal to 0 in the equation of plane, we get, and taking modulus in the numerator, we get this, and divided by square root of 2 square plus 3 square plus minus 1 square. That gives 5 by root over 14. For D, we have L is 0, M is 1, N is 0. These are the direction cosines of the normand to the plane. The distance of the plane from origin is modulus of 0 plus I divided by square root of 5 square. That gives I by 5. For question number 2, find the vector equation of a plane which is at a distance of 7 units from the origin and normand to the vector thrice I cap plus 5j cap minus 6k cap. Origin dagi 7 units lapa vector adu da perpendicular oiba vector na c oiba plane equation adu vector form the putu o. The normand vector to the plane is generally denoted by n vector, which is equal to thrice I cap plus 5j cap minus 6k cap. And the unit vector along the given vector is n cap, denoted by n cap, and equal to n vector divided by its magnitude, whose respective values are substituted. We get this, which is the value of n cap. The required equation of the plane is r vector dot n cap equal to p. R remains unchanged. N cap की value पीछे ले अदुगा p की value दे वहाँ द directly 7 पिरम ले. This is the vector equation of the plane which is at a distance of 7 units from the origin and normand to the vector is thrice I cap plus 5j cap minus 6k cap. For question number 3, find the Cartesian equation of the following planes. Makhada piriba planes singa sige Cartesian form adu putu o. The Cartesian equation of for this plane is r is replaced by xi cap plus yj cap plus zk cap, and perform the scalar product, we get 1 times of x is x plus 1 times of y is plus y minus 1 times of z is minus z equal to 2. This is the vector equation of the given plane, which is expressed in terms of vector. The Cartesian equation of this plane is obtained by r is replaced by xi cap plus yj cap plus zk cap, and perform the dot product, whose value is 2 times of x plus 3 times of z plus minus 4 times of z equal to 1. For C, the Cartesian equation of the plane, this plane is this dot this vector equal to 15. Perform scalar product, we get this, which is the Cartesian equation of the plane. For question number 4, in the following cases, find the coordinates of the foot of perpendicular drawn from the origin. Origin dagi makha plane asida singakpa perpendicular gi makhong adu puthu'u. Let capital L be the foot of the perpendicular drawn from the origin O to the plane. The direction ratios of the normand are coefficients of x, y, z respectively, that is 2, 3, 4. The equation of the normand passing through the origin and having direction ratios 2, 3, 4 is x by 2 equal to y by 3 equal to z by 4, each fraction being equal to lambda, say. Then solving first member with the last, that is x by 2 equal to lambda, gives x equal to twice lambda, y by 3 equal to lambda gives y equal to thrice lambda, z by 4 equal to lambda gives z equal to 4 lambda. Since n twice lambda, thrice lambda, 4 lambda lies on the plane, therefore the coordinates of this point will satisfy the given equation of the plane, that is 2 times of twice lambda plus 3 times of thrice lambda plus 4 times of 4 lambda minus 12 equal to 0. Solving lambda, we get 12 by 29. Therefore, foot n becomes 24 by 29, 36 by 29, 48 by 29. B and C are similar to Roman A. For D, let n be the foot of the perpendicular from origin O. N habesina origin dagi perpendicular to singapa perpendicular gi makhong adu uhilasi. The equation of the normand to the plane passing origin is origin dagi singapa normand adugi equation to the x by 0 equal to y by 5 equal to z by 0 makhoi khudimak lambda ga manahilasi. That gives x equal to 0, y equal to 5 lambda, z equal to 0. Since n 0, 5 lambda 0 lies on this plane, therefore the coordinates of this point will satisfy this equation, that gives lambda equal to minus I. Question number 5. Find the vector and Cartesian equations of the plane that passes through the point this and the normand to the plane this. Apiba point asi phawba apiba plane asidana perpendicular oiba plane gi equation adu vector amasung Cartesian form sing da puthu'u. For A gi, here A is equal to this, B equal to this. A is the position vector of the given point, and B is what? B is the normand to the plane is this. The vector equation of the plane passing this and normand I cap plus j cap minus k cap is r minus a vector dot n vector equal to 0. Putting respective values, we get this. Also, its Cartesian form is obtained when r is replaced by its position vector, and perform scalar product. We get this. After simplify, we get x plus y minus z minus 3 equal to 0. This is the Cartesian equation of the plane. B, similar to A. For question number 6, find the equations of the planes that passes through the 3 points. Apiba point ahum si phawba plane equation adu puthu'u. For A, The equation of the plane passing through the points, these 3 points, is x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1, whose determinant equal to 0. This gives the equation of the plane in Cartesian form. Expanding in first row, we get this. The 3 points are collinear because collinear. Thus, there are infinite number of planes. Line amada laiba point ahum yauba plane masing asidi masing thingamdana laigani. For B, the equation of the plane passing through the point this is the value of this determinant equal to 0. And simplifying and expanding in the first row, we get twice x plus thrice y minus thrice z minus 5 equal to 0. This is the required equation of the plane passing through the 3 given points. Question number 7. Find the intercepts cut off by the plane disk. Here this dividing 5 in both sides, we get this, and write x by something plus y by something plus z by something equal to 1, which is slope intercept, which is the standard form. The intercept cut by the plane are 5 by 2, 5 minus 5 respectively. Number 8. Find the equation of the plane with intercepts 3 on the y-axis and parallel to z or x plane. Z or x plane. The equation of the plane with intercepts b greater than 0 on y-axis and parallel to z or x is y equal to b. Using this formula, the required equation of the plane is y equal to 3. For number 9, find the equation of the plane through the intersection of the plane this and the point this. Plane ani si kaknaraga phangba line adu phawba apiba point asi phawba plane equation putu. The equation of any plane passing through the intersection of the plane this and this is first plane plus lambda times of second plane equal to 0. If it passes the point 2, 2, 1, then the coordinates of this point will satisfy this equation. Putting respective values, we get lambda equal to minus 2 by 3. Therefore, the required plane is obtained when lambda is replaced by minus 2 by 3, and simplifying, we get this, which is the required equation of the plane. Number 10. Find the vector equation of the plane passing through the intersection of the plane this and through the point this. Ahanbagi line plane ani si kaknaraga phangba line adu phawba apiba point asi phawba plane equation adu vector form the putu. The equation of any plane containing the line of intersection of the plane this and this is r dot n1 vector plus lambda n2 vector equal to q1 plus lambda q2. Formula sizinarabadi. Therefore, the plane containing the planes is r vector, n1 for the first line is this plus lambda n2 vector of the second line is this plus 7 plus q1 is 7, q2 is 9. We get this. If it passes through the point 2, 1, 3, then this point will satisfy above equation. For r, we have to put twice I k plus j plus 3 thrice k k. Perform scalar product of two vectors, we get lambda equal to 10 by 9. The vector equation of the plane is, put lambda equal to 10 by 9 in the above equation, we get this. Simplify, we get this, which is the required equation of the plane in vector form. For question number 11, find the equation of the plane through the line of intersection of the plane this and is perpendicular to the plane this. Ahanbagi plane ani si kaknaraga phangba line adu phawba ahum suba plane asida perpendicular oiba plane equation putu. The equation of any plane through the line of intersection of the planes this and this is first plane plus lambda times of second plane equal to 0. and put this equation in general form, we get this. If this plane is perpendicular to the third plane, then direction product of direction ratios, this in 1 into this plus minus 1 into coefficient of y plus 1 into coefficient of z equal to 0. Applying the condition for perpendicularity of two lines, we get this. Solving lambda, we get minus 1 by 3. Therefore, the required equation of the plane is put lambda equal to minus 1 by 3 in this equation and simplify. We get x minus z plus 2 equals 0. This is the required equation of the plane. For question number 12, find the angle between the planes whose vector equations are this and this. Plane anisigi marakta laiba angle putu haibani. Here n vector, n1 vector is this and the n2 vector is this. Using cos theta equal to this, we get cos theta is n1 n2 anigi scalar product to receive phangani, magnitude adusho receive phangani. Simplify toraga, we get this. Therefore, theta equal to cos inverse of 15 by root over 732, which is the angle between the two given planes. 13. In the following cases, determine whether the given planes are parallel or perpendicular, and in case they are neither, find the angles between them. Makhagi planes asi parallel natraga perpendicular oi habadu putu animak oidaba cases singdadi makhoigi marakta laiba angle sing putu. For first plane a1 b1 c1 7 5 6 asi a1 a2 a3 ki value ni. Aduga second plane gi A2 B2 B1 B2 B3 B1 B2 B3 na 3 minus 1 minus 10 ni mathang sina A1 by B1 gi value puthoksi A1 di 7 ni aduga B1 di 3 ni 7 by 3 lare A2 by B2 di 5 by minus 1 asumna A3 by B3 di 6 by minus 10 kakthana di minus 3 by 5 ratio singa samata manadre. Haibadi A1 by B1 ki value does not equal to A2 by B2, does not equal to A3 by B3, does not equal to sigimanung the ama hek yaw the plane anidu parallel oide. Therefore, the two planes are not parallel. For perpendicular, we have to find out this value A1 B1 plus A2 B2 plus A3 B3, whose values are 7 into 3 plus 5 into minus 1 plus 6 into minus 10, whose sum up is minus 44, which does not equal to 1. 1 ga manaram labadi perpendicular oigadabani 1 tadrabani nam. Therefore, the planes are not perpendicular. Parallel su oidre, perpendicular su oidre. Therefore, angle between them the cos theta c siznaraga puthosi formula c respective value piro sum up toro 2 by 5. Therefore, theta equal to cos inverse of 2 by 5. For B, we have A1 by B1 ki value the 2 by 1 later ni, A2 by B2 ki value so equal to 1 by minus 2, A3 by B3 ki value so 3 by 0. Amatta manadre, ratio since amatta manadra, therefore the two planes are not parallel. For perpendicular, we have to find out this value whose value is 0. This shows that the planes are perpendicular. For C, we have to find out A1 by B1 whose value is 2 by 3, A2 by B2 is also 2 by 3, A3 by B3 is also 2 by 3. Ratio khudimwak manare. Therefore, A1 by B1 equal to A2 by B2 equal to A3 by B3 implies the planes are parallel. For D, we have A1 by B1 is 1, A2 by B2 is 1, A3 by B3 is 1. This shows that the planes are parallel. For E, we have A1 by B1 is 4 by 0, A2 by B2 is 8 by 1, that is 8, A3 by B3 is 1 by 1, which is equal to 1. Manadre, therefore A1 by B1 does not equal to A2 by B2, does not equal to A3 by B3. This shows that the two planes are not parallel. For perpendicular, we have to find out this value, whose value is 9, which does not equal to 0. Therefore, the planes are neither parallel nor perpendicular. Case animak lokaladi akon bagisina perpendicular oidre, ahan bagisina parallel oidre, animak si punjalaga de Therefore, the planes are neither parallel nor perpendicular. Parallel so the perpendicular so they to intersect using cos theta c siznaraga formula potoxi pi by 1 by root 2 fange which is cos pi by 4 ni theta ki value pi by 4 plane ani adu mark angle to pi by 445 way. For question number 14, in the following cases, find the distance of each of the given points from the corresponding given planes. Makhada piriba points si mapa chanabada leiriba planes singa sidigi oba perpendicular distance put to u. The distance to the aikoina ax1 plus by1 plus cz1 plus the minus plus c whose modulus divided by 3 square plus minus 4 square plus 12 square ne. हाइबदी हानगी प्लेन दे यावरिबे x y z सिंग असि कोऑर्डिनेट सिंग रेस्पेक्टिव कोऑर्डिनेट सिंग असि पिसिलो 3 ना लेफ्ट थांगो अ मदुगी मॉडुलस ता रूट ओवर कोएफिशिएंट सिंग स्क्वायर के सम हाइदि 3 स्क्वायर प्लस minus 4 square is 4 square माने plus 12 square whose value is 3 by 13 which is the distance of this point from this plane. For B, the distance to plane equation सिंग असि दा यावरिबे x y z ता 3 minus 1 1 पिसिलो मदुगी मॉडुलस ता divided by 2 square plus minus 1 square plus 2 square that is 3 mathak ki asina sum up tar the 13 pange sumna c gi dusu asumna plane gi equation asida yauri ba x y z sing da 2 3 minus 5 sinjalaba 9 left thanga aga madu gi modulus log to whole divided by square root of 1 square plus 2 square plus minus 2 square that is 3 9 by 3 to 3 pange. The distance to the matangi the soup plane equation asida x tana minus 6 y dana 0 z to 0 pisilo madugi modulus star root over divided by root over 2 square plus minus 3 square plus 6 square that is 7 14 by 72 pange sina putokada ba perpendicular distance singa done. Thank you for watching video.